Hello all. Today we will try to find out the basis and dimension of a vector. Okay. So question is, find the dimension of the vector space spanned by the vectors 1 1 minus 2 0 minus 1 1 2 0 minus 4 1 0 1 3 minus 3 2 2 3 0 minus 2 0. Okay, and find a basis for that space. So what is basis actually? Basis is nothing but it's the unique columns. Okay, it is the unique columns. If I see, if I try to convert this four vectors into a matrix, we will have a 4 by 5 cross matrix. Okay, in this we will try to find out the columns which are unique. Means we will try to find out if any other column is a repetition or a scalar multiplication of the other columns, then that will be not considered as a basis. Basis is nothing but as a unique columns in the given vector. So first, to find the basis, condition to find the basis is, the first is the vectors which form the vector space. So here there are four vectors. So these all the four vectors can make the basis of the space. Okay, but we are not sure that all the four are considered as basis or only two or only three out of the four. Okay, so we'll try to check the next condition. What is the next condition? They should be linearly independent. Right? Linearly independent means those should be unique. So how to do this? How to find out this? So procedure is, put these vectors in a rows of a matrix, what I said earlier, perform the elimination, normal row and column operations, right, which we did in the previous classes. So then after performing the eliminations, row that have pivots are independent. Fine. See, come here. So I have taken these all the four vectors in a matrix form. 1 1 minus 2 0 minus 1 1 2 0 minus 4 1 0 1 3 minus 3 2 2 3 0 minus 2 0. Okay, so what I am doing, so considering first this as a pivot, okay, I will try to multiply minus 1 with the row 1, then add it to a row 2. Okay, and I am performing one more operation on this pivot. See, when we are considering first pivot, okay, it's our responsibility that all the elements under that pivot must be 0. So 1 is 0 here, so the other part is minus 1. So minus 2 multiplying with the row 1 and then adding it to the row 4. So it will give you all the three elements below the pivot as 0 here. Okay, you know this already. I am still giving the same point so that you can recall. Sorry. So now considering this as a pivot now. Okay, considering this as a pivot, perform the row operation. So finally you get something like this. So what is this? See, these are the three pivot elements on which we perform the row operations. Then we have got all else as 0. Okay, then when these, whatever you can consider it as a row or a column. Okay, considering all the three pivots which lie in those rows or column will be considered as linearly independent. Okay, so here whatever we have taken in a matrix form is from a row vectors, so we will consider as a rows which consists of pivot. Okay, so these are called as linear independent. So therefore the basis is the rows which consists of these three pivots, that is 1 1 minus 2 0 minus 1 0 1 2 minus 4 2 0 0 1 1 0. So it's not compulsory that you write the result of the matrix after the operation. You can write the same vectors which are given in the question also. So that is this one, this one and this one. Okay, so these three vectors are the basis vectors. The advantage of writing the result vectors is, see, whenever you are doing some row operations, there is a chance that you interchange the rows. Okay, there is a chance that you interchange the rows. Interchanging the row means you are making fourth row vector into third row vector and third row vector into fourth row vector. So there might be a possibility that you make a mistake writing the vectors. So it's better whatever operations you have done and the result should be written in a basis vector. Okay. So dimension of vector space, the part B in the question is dimension of vector space, that is, it is nothing but as number of vectors in the basis. So how many vectors are there? There are 3 column vectors, 1, 2 and 3. So these are the 3 column vectors in the basis. Okay, so that is dimension of 3. Okay, thank you.